All right, let's get started. So thank you everyone for coming out. And thank you for Roberto for letting me do this presentation. So I'm here with IEEE and also SWEET, Society of Women Engineer. And we're here to host a small little workshop of SolidWorks. This is my first time doing an actual Zoom workshop, so I'm sorry if it's not the best. So first of all, we're gonna talk about a little bit of a little bit about SolidWorks, CAD is, um, and we're gonna go later on into a little bit of a follow along. If anyone has SolidWorks, if you could get into Citrix. I'd also like to thank SWE for joining us. We have Julie in the chat, and also I'm sorry if I mispronounced your name. It was the man, the Mel. I don't know if you could correct me.
Thelma.
Okay, sorry about that. And we also have Roberto, president of IEEE here.
What's up, everyone? How's everyone doing?
Pretty good.
Good. This will be a good one, man, for sure.
All right, so let's get started. Let's see. So first off, we're going to start off with what is SolidWorks? Basically, it is a CAD tool. So CAD is basically a computer-aided design, typically used for aiding people in creating, I guess, 2D models, 3D models, helps in modifications of models. You could also run analysis on certain models, and also helps you optimize designs.
Because in your internship, you're part of the purchasing department, right?
Yeah. Sorry?
Sorry, my bad. That was an audio issue. Keep going, my bad.
Oh, okay. So yeah, also with these, with SolidWorks, specifically, you could create like little assemblies. So you create like certain parts by themselves. You could put them together later on and just make sure everything fits before you go ahead and like manufacture everything. Give me a second. So when you start up SolidWorks, first thing that's gonna come up is this little screen over here. So it's gonna, let me see if I could get a laser. Sorry, this is also my first time using Zoom on computer. Oh, here it is. So you're gonna get this little this page where you could create. Oh, whoops. Did it work? Laser pointer. Where you could go over here and create, select to create a new part or a new work area for you to start. You have the option to create a part. If you already have parts set up, you could start an assembly, put everything together, or you could create a drawing or modify a drawing if you do have one. Basically, these are the steps that you're gonna take to just start the parts. Basically, just click new file, click part, hit OK. And then it's gonna take you to this interface over here where you're gonna have basically an area for you to select a plane. So we are working with 3D models. So you're gonna have 3 dimensions, usually your front, your top, and your right plane. When you go ahead and you're gonna start your first sketch, so you're gonna start off with 2D sketch before you actually start your design and actually make it into a 3D model. You're gonna select which face you want your model to be made on. Well, your drawing to be made on, so you could later on add the 3D features. So this is going to be one of your best friends for SolidWorks. So here you have all your little sketch features where you do your 2D models, well, your 2D drawings or whatnot. And you have your sketch option, which is going to allow you to select a plane. The plane is gonna shift to the front of your screen, and then you're gonna have like little options like a line option where you could draw with lines. You could draw a square, a circle, and other little features. We're gonna get into it in the demonstration later. And then you're gonna have where this feature area is at, these features where you could either extrude, make the part go outwards, so extruding it outwards, create like some sort of revolve. You also have little cut features and fillet features, which just kind of like rounds out the corner. So here on this area, we're gonna have basically where all our planes are at, our histories of our parts, basically everything you've done, like every feature, every sketch, it's going to be in this area over here, and you're able to go back and click the sketches and all those things if you ever want to modify it later on in the actual, like while you're doing the drawing. Then here are different little areas where you could go ahead and choose like different views for your part. Like let's say if you want to make it transparent and only like the outer lines show, you could go ahead and do that. Or if you want to change the view of the part over here, you could hit, and it has a lot other little neat features. And of course your graphic area, which is going to be where your part's going to be at. So after this presentation, if anyone else does want to like get into a little bit more into SolidWorks, what I would recommend, I'm actually taking a course with them right now, Solid Professor. So this site typically gives you, how do I say this? It allows you, it gives you a course, and after you're done with the course, they give you an actual little coupon that you could go ahead and take your tests to become SolidWorks certified. So I believe they give you up to 2 coupons. So you could go for your associate level of SolidWorks, or you could go for your professional level of SolidWorks after you're done with the actual each set of classes. You could always also chat with them. They're always open to answer any questions. I talked to them. They were super nice and everything. They tell you what are the best deals and everything. They do have a student store, which is what I recommend everyone here, if you're interested in getting it, the course, to go into it. So typically the program, first of all, we're not sponsored. I just really like this website. But typically it's $50 a month for the actual course. But if you are a student, they give you a discount of $75 a year. So instead of paying $50 a month every month, you just pay $75, and it's for the full year. And each certification costs, I think, $99. So you do your associate, then you go for your professionals, it's going to be $200. So you're saving money, from my point of view, anyways. You're saving money. And I think they do help you out with like if you fail a test or something like that, they work with you and they set you up with one of their team, so they could help you succeed on your next try, and they'll give you an extra try with that. How can we access this recording? Okay, thank you. All right. Just want to open the floor up for any questions before we get into the actual design process. Oh yeah. Also, another learning source is LinkedIn Learning. Super good. It's free. and they give you, I guess, their own certification. It isn't like a SolidWorks certification, but it does automatically post it to the LinkedIn like page. All right, and I guess if no one else has a, well, it's free for FIU students. Sorry about that. So you wouldn't have to log in with your FIU account. But if no one else has any other questions, I guess let's get started. So didn't want to do anything too complicated to begin with. Here's a little part that we're going to be working on. If you want to take a picture with your phone, or just going to give it a few seconds. All right. And everyone got it that's going to follow along? No, yes. Also, in the chat, if you could sign in as well. There's a link in the chat. Oh, sorry, and it is for SWE. Let's share. All right. So, your page might look a little different than this. I'm just making sure. Can everyone see the SolidWorks page?
Okay.
Okay, perfect.
Yes.
So your page might look a little bit different than this, depending on which version of SolidWorks you have, but typically it all works the same. Typically when starts up, you're gonna have a nice little page like this, gonna tell you, ask you if you want to start a part, an assembly, a drawing, if you want to open something that's already created. You also have this tab over here that if you have like some sort of template already made, you could always go ahead and try to and open it up, or yeah, open it up. And yeah, so once you go ahead and click new part, want to open it up, and it's going to take you to your page with your interface. And we're going to start off with a sketch. And I'm going to say we're going to start off with our, yeah. After that's class. Yeah, no problem. And yeah, it's going to be recorded, and the video is going to be uploaded to YouTube, so you could always come back, go back and actually watch the video. But and thank you for coming. All right, so we're going to start off with our top plane. Sorry, I have my drawing to the side. And for this drawing, what I want to start off with is a circle. So I'm going to start off with the outer circle. And I'm going to create the circle. The drawing says that it has a diameter of, oh.
Can I ask a quick question?
Sure.
How do you know which plane to start off with?
Typically you could choose whichever one you feel most comfortable with, but you could also think of it as a drawing, like a 3D part. So how do you want it? When you extrude it, or when you create the 3D model, which way do you want it to face, basically. But you could do you could choose any plane, to tell you the truth, as long as you know what you're doing or whatnot, or how it's going to end up looking, you'll be fine. But one thing I did miss, which, let me erase this. So this model is going to be in inches. So we're going to have to go down here. I have my settings set to millimeters, grams, and seconds. But since we're going to be using inches, we're going to have to switch to the American units, which are going to be inches, pounds, and seconds for anything. And then we're going to do the whole entire thing again. We're going to go, you don't have to hit the sketch button. You could actually hit whichever sketch feature you want, which we're going to do the circle. So the circle, you have two different types of circles. Typically, the one that we always use is just center point circle, which allows you to pick a point anywhere and then pull the circle out, and you could choose it to any I guess radius you want. What I do, I basically just set it down, pick any radius, and there's this tool over here called Smart Dimension. Smart Dimension, what it's going to do is going to allow you to actually pick what is the actual, well, the diameter of the actual part. Let's see, it was 5.5 for the diameter in inches. And there you go. From here, as soon as you have your 2D drawing, you're gonna go ahead and, let's say we want to extrude it a certain amount. We hit, oh, sorry, a little bit fast. We go to our features, and then we hit extrude. It's gonna give you a little preview of what it's gonna look like, more or less. Typically, you have different types of weight, different types of, I guess, directions. You could I forgot what these are called, but it just, you could set these up to have it. Let me make it a little bit better so you could actually see what's going on. So you could put like a mid plane like extrusion, which extrudes it both ways. Let's say you want to do like a blind extrusion, which allows you to choose a certain diameter to where you want to like actually extrude it. You have these other ones, but we can't really show them right now because of it's just a different feature. You need something else for it to go up to. Or yeah, I mean, like, you have offsets and all that stuff. But what we're going to be using is blind. And we already know how much we're going to extrude this by, which is 0.75 on the drawing. And to go ahead and actually get that, for it to stay, we're going to hit this OK button, and it's going to give us this nice little disk. So what we're going to want to do is go back over here and let's top right. Go ahead to the top again and make another circle. So we're going to click the circle, which plane we want to start off on, and we're going to create another circle, just anywhere, any size. And then we're going to use our Smart Dimension to set it to the size that we want to, which is 2.75. And then we're going to go ahead, click OK, go to extrude. And again, so it's from the bottom, 2.25 minus. And by the way, SolidWorks also does math. So if you have, I guess, like something that you want to add or subtract or anything like that, you could always do that as well. So we know from the bottom to the top, the drawing is telling us that it wants it to be 2.25. So we know the bottom is 0.75. So we could go ahead and we know we already have the bottom already checked out, the 0.75. So we want to remove that from the whole entire height. So we're gonna just go ahead and do 2.25 minus 0.75, and that would give us our height. And then we hit OK. All right, so we have this now, but we want it to look a little bit nicer, the edges at least anyways. We have these features over here. Well, first we're gonna have to, oh, sorry. Let's see. Sorry, I need to move. Yeah, you could just press enter as well. I need to move this thing to actually access all my features. The little toolbar for zoom. So we have these features called fillets, which allow our edges to be rounded off. And usually it's by radius. So you have this little spot over here where it asks you what radius you would like to fillet your part. What's the radius you would like to fillet your part? On the drawing, it tells us, what was the fillet? Where is it? Okay, fillets are all rounded to 0.25 radius. So we're gonna go 0.25 and then we just hit enter. We could go ahead and it gives us a nice little round edge so you don't cut yourself on it or anything like that. And then we also notice in the drawing there is a hole that goes through the, well, it doesn't show it in the drawing. I didn't put the figure up, but there is a hole that goes through the middle. So we're gonna go ahead and go to our sketch again. And I believe, what is the diameter? Space. So there is a nice little feature where you hit space and you could actually get this little menu where you could just easily move to whatever spot that you want. So we're gonna want to draw a circle here. If I'm not mistaken, what is the radius of the circle?
I think the diameter is 1.5 for that one.
1.5?
I think so.
Oh wait, yeah, sorry, I just saw it. So that would be 0.5. So we get that there. We exit, well, smart dimension, exit, and we go ahead and there's this little feature over here called extrude cut. So with extrude boss base, it's gonna go and it's gonna actually create a 3D part. It's gonna create material. With this, you're taking off material. So we want this to go all the way through. Let's see. All the way through. So you just go in this little menu and it has it here. Everything, and then we hit OK. And we're gonna have a nice little circle that goes all the way through to the bottom. And it's asking us that for a chamfer over here in this little edge. So we want to remove the sharpness of this edge. And so the chamfer is kind of like a fillet, but instead of being rounded off, it's more like a triangle type of thing, a right angle. So the chamfer is going to be in that little menu over here where the fillet's at. There's a little arrow. You click on it, and you're able to just select what you want to chamfer. And it asks you for the degree, the degrees of the actual triangle, and then you also asks you for the depth of the actual chamfer. So it's asking us for 0.08. So we're gonna go ahead, do that. It's gonna give a nice little chamfer there. No, it does not. So we have this already set up, everything's set. Now what we're gonna want to do are those little circles that are all around the edges. So we're gonna go ahead, not the edges, like the inside of this disc. I'm gonna go ahead, center our part, and we're gonna create a circle on this part. From the center of our part, sorry, question, okay. From the center of our part, and it wants that radius to be 4.25. Diameter, 4.25. Now we have this feature where we could set this line to be for construction. So this line it's not gonna be part of the drawing or part of anything that's gonna be cut. This is just used specifically for placing things or for actually using point of reference for SolidWorks. So our part could stay fully defined. So it says it wants it. Well, an easy way to do this from my point of view, there's this thing called the center line. We also use this for construction of parts just to create a reference. So we're gonna go ahead and create a center line from here to the bottom. Then hit escape to get out of there, and then create another center line through the center. And we have right here specifically where they want us to put our circles. So makes it a lot easier for us. So we have our circle, which we actually didn't really have to do that. We could have just done with this one, or we could have done, it's 4 circles, 50, 0.5. 0.5, and there actually is this neat little feature over here. Well, first, actually, it's over here. Let's go back into our sketch, because I believe.
Are you looking for a circular pattern? Because I know if you go to features, it's under the little tab of linear, I think.
Yeah, but we could also make a circular pattern of the actual sketch.
Mm-hmm.
So we could go over here, click which direction we want it to go. And we have this little setup over here where we could, typically we're gonna want equal spacing because we want all of them to be equal. It gives you the amount of actual objects you want to make. Let's say you want 5 or whatnot, or you want like 6. and it keeps them equally, and it's traveling 300 degrees, but we just want 4 for this project. That's what they're asking us for. Then you're going to go ahead and click OK. From here, you could go ahead and exit the sketch and actually use our extrude function, where we're going to select the sketch, and we could select, if I'm not, no, you, give me a second. All right, extrude, extrude. Here we go. So yeah, you would go into this little box. If it does take you out from the extrude, you would go into this little box, and then you select all the parts that you want. You highlight all the parts that you want to actually extrude. After you're done with that, you would go ahead and want you to go through all of it, and then you hit OK. And it's going to create a nice little clean cut all the way through. And that is your part. Now, let's say if you wanted to go ahead. Let me see. 2 in the chat. Oh, thank you. So let's say if you wanted to go ahead and save this part for later or anything like that, you could always go into save. You go save your part however you want. I'm not sure if you could see the actual pop-up menu, or would I have to change? All right, does anyone see the actual pop-up save menu?
Yeah, I see it.
Okay, all right, just making sure. So yeah, name your part whatever you want. Like part or something, and you have different little types of different files that you want to I mean that you can save them as. The one most used is just basically part. The one that I like well, that I specifically use the most is STL. So STL are usually files that you go ahead and you use for 3D models that you're going to 3D print and things like that. So like slicers programs like Cura and stuff like that, they typically just read STL files, and those are the ones that they use for 3D printing. But let's say we're gonna save it as a part somewhere, I guess in documents, and you're set, and that would be your whole entire your part. If you wanted to, I could get a little bit more into, I guess, like how you would set this up to be 3D printed or whatnot. If anyone is interested, we still got, I think, a couple of more minutes.
Can you do that?
Yeah. So.
Also, if you wanted to analyze it, like for stress or strain, could you do that in this program, or you have to put it in like ANSYS?
Yeah, you could do it in this program. I never learned how to do it in this program. I ended up using ANSYS. I could give, but that's gonna be a little bit of time. But if anyone ever wants a workshop on that, I don't mind giving that. That takes a little bit. But before anything, let's go ahead and save this as a STL. Desktop, no part. It's gonna ask you for this. It's gonna create like a whole mess load of like little lines and everything. This is just creating it for, well, setting it up for the actual slicer to be able to read it. And you're gonna hit yes. Let's minimize this. Let's get out of this. And right. Right. Oh, no. So let me share. So this is Cura. Cura is basically a slicer. What a slicer does is it gets a part that you already created and it kind of just like slices it up into like little layers for the 3D printer to actually be able to create it, because the 3D printer, what it does is it creates a part layer by layer. So it has to slice up each and every little section of it into a certain layer for the 3D printer to be able to actually uh, create the part on what's that thing called? Using G code that's made by the actual program. So we're gonna go ahead and drag in our part. It's a little bit bigger than I thought it would be, to tell you the truth. So typically you have different little features on the side where you could choose what you want to do with the part. First things first, you would have to select the part. With our first feature over here, just making sure it is sharing. Yeah, it should be. So we would select our part. Before anything, your right click would be to move the screen of this program, and then your scroll would be to zoom in and out. And if you click in the scroll, you could move the screen. So with this program, you have the ability to either move it. You could either set by how much you want to move it to whatever side, whether it be in the negative or the positive, or you could just simply just pick up the part and just move it wherever you want. You also have these little arrows that you could go ahead and move. You have a little scale button. So let's say you didn't want to use that much filament, or you wanted to scale down the part or whatnot, and it's something that you know it's not going to be practical, or you just wanted to print just to print, you could go ahead and scale it in different directions. So we have uniform scaling on, which is going to allow us to scale uniformly, but you could always turn that off and have them scale in different directions. But we want uniformly. So let's go 100. Yeah, we would have to do. Or we could just reset, which makes it easy. And you have the ability to also rotate your part. So some parts. All right. Thank you for coming. Have a good one. So some parts, like you saw when it first came in, it was slanted like this or whatnot. So if you build it like this, you see all this red over here, it's basically telling you that this is all gonna need supports. That's a lot of filament that we're gonna have to use just to make this part. So our main goal is making sure we don't use that much materials, but we also want our part to come out nice and clean. So you would try to avoid any holes, any gaps, or anything like that. So we could go ahead and move that to have it to a point where the actual holes are at a spot where we don't need any supports for them. And then you have the option of mirror. Never really used this option. This one I have not used either. It's actually a new feature. I just downloaded this version of Cura I think like a day ago. I haven't used it. Typically don't really use these two. I mostly just use these because the part I usually have, you have the ability to also select create like copies of parts, where you could go ahead and move them or whatnot, but we're not going to do that. We're going to delete them. And we go over here is going to be where our main setup is going to be at. You could either, they have already a custom setup that you could do. If you want supports, you could put them on. If you want adhesion for the build plate, which is basically a little thing that prints around the part so it sticks to the bed. It's just like a little layer of filament on the floor, on the part, under the part, to make it adhere to the actual bed plate. Depending on what material you want. I know with ABS, typically you want to use that because it tends to warp a lot when it's printing. Let's see. I typically don't really use this. I always go to the advanced, which gives you a lot more control of the actual 3D printer, or how it's going to print out if you want a certain layer height. So each layer has a height, and you could set any layer you want. Typically, your nozzle that it comes with is 0.4. So you want to keep it somewhere under that, and they typically recommend it to be, I guess, half of it. So we keep it like around 0.2, but you could keep it like take it down to 0.1, and it makes it really nice and fine and everything. Depending on which part, how the part is set up. You could create like the thickness of the actual wall of the part. So typically it prints it out. Let me see. Extra. Yeah. So yeah, typically it prints it. It has, how would I say it? How would I say this? So it's, the inside of the part is hollow, and it tries to use at least amount of filament by doing that. You have I don't know if I could explain it. Let me see. There's a feature up here, if I'm not mistaken, that allows me to show the print preview. Unless they took it off. Printer manage. Oh, here it is. So you could see more or less how the part actually prints. Wait, where was it? Print preview, few layers, X-ray. How do I remove this?
I think you need to slice it first.
Oh, yeah, wow. I can't believe I forgot. Yeah, so it gives you like the actual preview of how it's going to print. So you see how it has like all these little gaps and whatnot. So it creates little patterns inside that it uses as much as possible so it could save space. This is basically called the infill. The infill is going to tell you how much of the actual part is going to be filled up or whatnot. You'd be surprised how much material you really don't need for a part to actually still function. Well, it depends on what it's going to be used for. Also, you could completely make this solid, so this is going to be completely, there's going to be no patterns, completely solid, or you can make them slight as possible so there's not that much infill. All depends on the application. Oh yeah, definitely. Hold on, let me see. The patterns, there's a little menu over here where infill, materials, support, will play. What was it? I did take it off. Should be an info. Oh, wow. I was looking at it this whole entire time. So there's different types of little patterns over here. You could do like gridded line, triangular, let's see, cubic, Let's go ahead and like click on one of them so we could see how it changes it up. So you see how it changes it to a different pattern or whatnot.
Is there a way to like decide which one works best for like what you want to print, or is it kind of just like base it off of, I don't know.
Actually, there is a way that you could import this into ANSYS, and you could run an actual simulation on this, and it tells you, it gives you like the stress analysis. So typically, you know, these line, it's all layers, and you know, anything that pulls on this, let's say this is stuck to the ground and it pulls on it, it's gonna decide to create create like some sort of like it's gonna want to rip it apart or what or not. So the layer adhesion isn't like the best, so it is gonna try to rip it apart. So you would try to think about what the application is. You see that these are squares, so you know if you wanted to put force down on this, these squares, you're gonna put force on this. You would have to run basically just a simulation on ANSYS, create the part like this, tell it that it's gonna be like this, like these little infills, and see the results of that. I know there is a channel, CNC Kitchen. He does a lot of like stress analysis on certain parts, different patterns, different materials, and things like that. I recommend seeing him. He goes really into depth on how you could actually check what pattern is gonna be stronger for your application, what pattern uses the less amount of filament and all that stuff. So it's let me see. I'll post it in the IEEE chat. The video. I know I saw it somewhere. I just need to look it up. But yeah, basically that's most of it. So we have, yes. Oh, sweet. Thank you. There, it's in the chat if anyone wants to see it, I think. So yeah, after that, you know, you have your speed, the speed you want the printer to print at, the temperature of the plates, PLA, usually 200 to 215, somewhere around there, depending on your climate in your house. Bed plate usually recommended around 60. I'm assuming their generic was 50. Infill pattern, typically, I guess if you're not using it for heavy applications, 20% would be pretty good. But you could change it to 50, like I was saying. $50 makes it a lot more infilled, and you could create it all the way up to 100. And makes it basically solid. And then your cooling, fans, I always just keep them at 100%. Travel, Z-Hop, basically every time it prints a layer and it's done with it, Z-Hop retraction is basically as soon as it's done with that layer, moves it up and goes to the spot that it wants to go to, and then it comes back down. Supports, we talked about that already. Supports just help things stay up. So if there's like a little, like, let's see, let's remove preview, prepare. So let's say this is on this side and you want it to print like this, but it's going to be in the air. It's going to mess up your print. It's basically going to print material here that you could remove for it to print it in this angle. And then build adhesion. I believe we talked about that already also. And dual extrusion, do not have one. I have not played around with this. Thinking of getting one later in the future. And I believe that is it. Like, as soon as you're done with your part, let's see, lay flat. Oh, wrong way. Lay flat. As soon as you're done messing around with your part, you say you want it like that and everything. You just go ahead, save it. Slice it up, save it, and save it to SD card. Or if you have your 3D printer connected to your computer, you could run the program. And I typically don't recommend hooking up your computer to your 3D printer, because I've heard horror stories where someone hooks up their computer to the 3D printer and something happens during the night and they come back and the 3D printer completely just fries the computer. So not recommended. Usually SD card isn't that expensive and these files aren't really that large. So recommend that all the way. But yeah, that's everything. Now you know how to create parts, you know how to 3D print. You could go ahead and create a robot, create a part for a robot, work on a rocket, create something that you want to do, print it out, put electronics in it, and go to work.